Hello everyone, welcome to Weekend in Sarki MEP classes. Hi to all the students, engineers, architects and designers. Today we'll be talking about module S4 which is Smart and Intelligent Buildings. Hi, I'm architect Neha Vasin, the owner of Raman Design Studio and also Vinaya the Learning Platform. So we learned in module 2 about sustainable design principles and strategies. Let's talk about it again. Uh, First is site design, second is energy management, third is renewable energy, fourth is sustainable building materials or selection, fifth is water management, sixth is indoor air quality, seventh is alternative energy, eighth is environmental systems, and ninth is environmental assessment methods. So what is intelligent architecture and structure? Building intelligently is one of the today's leading questions worldwide, as design, architecture and urban planning have to urgently find answers to changing global circumstances. Intelligent architecture takes care of new approaches and ideas such as drastic weight reduction, inbuilt seismic flexibility, functional integration, incorporation of green building concepts, and development of sustainable combinations of materials to support minimization of environmental damage. This is the anatomy of intelligent building system. Like what are the inputs, your LAN wire, WAN wire, your Ethernet, internet and everything that works for sensors. Then we take a backup, we restore, there's a building control system which backups everything and tells the building the output which is kinetic or static and how the entire building system works. Let's discuss what is an architect's role. In the case of new construction and most building renovations, the architect is the main interface for the building owner. It is the architect that develops the owner's facility program and assembles a design team, both of which are critical to the overall succession of the project. With such a prominent role, the architect heavily influences just how smart the building will be. Surely, architects understand that the control, monitoring, and automation systems are an essential aspect to a smart building. In the case of new construction and most building renovations, the architect is the main interface for the building owner. It's the architect that develops the owner's facility program and assembles a design team, both of which are critical to the overall success of the project. With such a prominent role, the architect heavily influences just how smart the building will be. Surely, architects understand that the control, monitoring, and automation systems are an essential aspect to a smart building. However, architects also understand that it's not just control systems that comprise a smart building. The fixed attributes of the building, such as the initial siting, the structure, the envelope, windows and interior layout, also play a major role in how smart the building is and how the building will operate. Remember, the best building control systems cannot compensate for the worst building structure and layout. Let's understand what is the life cycle cost of a building. As you can see, 25% goes to the maintenance and the alterations in case of renovations. 25% goes to concept design and construction and 50% goes into the operations, the energy that is taken to operate the building. Now, smart buildings can reduce both the construction cost of the technology systems as well as the overall building operations cost. The cost savings from the smart building approach results in added value to the building as evidenced by lower capital, which is capex, and operational, which is opex expenses. Citing the building. Architects frequently help the building owner in selecting and acquiring the building site for new construction or for existing buildings in assessing current conditions and updating a survey. Why is the site selection process important to become a smart building? Because it is a long-lasting, a 40 to 100-year decision. This specifies of a site, the specifics of the site, the topography, climate, and available public utilities will affect the design and construction of the building, possibly including the deployment of specialized building systems such as seismic, tilt, corrosion, and ground pressure monitoring. Also, the general area surrounding the specific site is critical. Proximity to transportation and infrastructure to other businesses, schools, colleges, and to skilled labor pools may be important to its long-term success. Materials. The architect and the design team select the materials used in the building. These decisions are sometimes a balancing act between constructability, aesthetics, durability, regulations, and cost. These decisions are important because materials deteriorate and wear out. The result may be condensation, corrosion, stains, moisture retention, bending, rot, fungus, and a host of other negative properties. Materials are important because they will affect the ongoing cost and ease of maintenance and operations, requiring servicing, cleaning, repairing, or replacing. The selection of materials should focus on the long-term use and cost of the materials and the minimization of maintenance, possibly through standardizing the products. Coordination. Architects are generally involved with coordinating the information and work of the design team members. Later, in the construction phase, a construction manager may coordinate the work of the contractors. Coordination in the design and construction phase is especially essential when building control systems are being integrated, a critical element of a smart building. As the design team leader, the architect can endorse a compliance statement for integration responsibilities that each of the designers and engineers can insert in their particular specification division that would cover both the design as well as the eventual contractors. Sustainability and adaptability. As the built environment faces the impending effects of global climate change, building owners, designers, and builders can design facilities to optimize building resiliency. Building resiliency is the capacity of a building to continue to function and operate under extreme conditions, such as and not limited to extreme temperatures, sea level rise, natural disasters, etc. Building adaptability is the capacity of a building to be used for multiple use and in multiple ways over the life of the building. For example, designing a building with movable walls, partitions allow for different users to change the space. Additionally, using sustainable design allows for a building to adapt to different environments and conditions. Genetic architecture. With the confluence of advanced biogenetics and high-level ciphering in the late 20th century, the subsequent completion of the Human Genome Project, we in the present day are surely witnessing the evolution of an unprecedentedly progressive era. The advent of this radical epoch is bound to transform the way we think and interact with our environment and the world at large. One such field of futuristic interaction would be genetic architecture, based upon the very fundamental philosophical notion of genesis. The related design concepts speculates and Ivan appraises the generation of skin systems from existing technological researches for cladding materials of the buildings. So here is an example of a smart facade. This structure is called a cellulose structure, as you can see on the picture. Thank you for watching this video. Thank you from architect Neha Vasin and also engineer VK Jain sir.
This particular series has been created using ChatGPT, and thanks once again from Neha Vasil and myself, Vikesh Jain.